This morning, our first session is being presented by three speakers. Feng, who's a data engineer at Western University. Adam Metzler, who's associate professor in the Department of Mathematics at Wilfrid Laurier University. And John Thompson, who is instructor in the Department of Mathematics at Wilfrid Laurier University. And they're going to be speaking on work that's been done at the Financial Wellness Lab, which is an industrial academic collaboration whose goal is to enhance the financial well-being and financial resilience of individual Canadians. Using data provided by its corporate partners, the lab applies cutting-edge techniques from data science and machine learning to understand the causes and symptoms of financial stress and to identify strategies that can help those individuals improve their financial well-being. Originally funded by the CCAM at Fields, the lab is currently funded by the Canadian Payroll Association. And today they're going to be speaking to us about machine learning, financial stress, and investment behaviors.
Great. Thank you very much, David, for the introduction. And thank you to the organizers for having us. And thank you to everybody out there for devoting some of your Friday morning to what we're going to be talking about. We're really excited about this. I think our title might be a little bit ambitious. The lab, which I'll talk about in a moment, sort of has two real research themes. One is on financial stress and the other is on investment behaviors. I think we're going to talk almost exclusively about the investment behavior side of things. Financial stress will be time permitting, but I am not optimistic that we're going to get there. Could we, and I'll just add one thing, John is currently a postdoc at Laurier, but he's recently landed a job at UBC Okanagan, so congrats, John. He'll be starting there soon. Leon, do you mind moving me ahead to the second slide? Perfect. So here's an outline for the morning. I'll talk a little bit about who we are at the Wellness Lab, a little bit of advertising, what we're doing. Then we will describe the data set that we've been working with, that we got from a large Canadian investment dealer, and some of the things we've had to do to just, it's big, and just kind of understand what it is we've got and what we're working with and what we can do with it, the types of questions we can ask. And then we'll spend a lot of time talking about the unsupervised clustering that we've done with this data. We'll talk a little bit, just overview some of the techniques that we considered, that we used. We'll talk about the algorithm that we ultimately decided on. We'll talk about feature engineering, which is something that we've spent months on. Really important to get that right. We'll talk a little bit about dimension reduction. And finally, we'll get into sort of once we've made all of these decisions about how we're going to analyze things, some of the things that we've observed. As I mentioned, we'll talk a little bit about financial resilience. If we have time, I don't expect that we will. Algorithmically, we're dealing a lot with survey data here. Eventually, we might get some more objective data, more hard data. And anytime you're dealing with survey data, there are their own challenges. So we'll get into that if we have time, but I'm not making any promises that we will. Thank you, Leon, you read my mind. So who are we? The Financial Wellness Lab. It's hosted at Western, and it involves a lot of researchers at Laurier as well. And it's essentially a big industrial academic collaboration. And what we want to understand is we want to understand financial well-being, financial resilience. In particular, we want to understand how people can make better decisions, or how people can make decisions that are resilience enhancing, right? And so investment behaviors are part of those. What can you do to put yourself in a better position for retirement? But we also look at a lot of other things, spending, savings, housing. And so we've got a really big group. We've got a lot of corporate partners that I'll talk about. We've got a lot of researchers involved. We've involved a lot of students, many of whom have gone on to PhDs. We have a few full-time data engineers like Leon, who do 98% of the heavy lifting here. And we've even talked to a few policymakers as well. We've talked about some of the things that we're finding in future, possible future collaboration. So that's kind of what we're trying to do. We're trying to use ideas, cutting edge ideas from data science, from machine learning, to make sort of objective prescriptions, how people can make better decisions to enhance that resilience, their overall well-being. That's sort of our ultimate goal. And the knowledge transfer is and will be facilitated by the industrial partners. So, the Canadian Payroll Association right now is putting together a website to help individuals diagnose their financial well-being and potentially identify some focus areas that they could work on to sort of move up the spectrum a little bit. And yeah, let's move on, Leon, to the next slide. So just to give you an idea who the team is, we have 2 full-time data engineers, Leon, who's here, and we'll be presenting, Nathan, who's not here, who's working more on the financial resilience side of things. We've got a project manager, Chuck Grace. He is an instructor at the Ivy School at Western. He is fantastic at what he does, liaising between the academic and the corporate partner side of things. We've had 3 postdoctoral fellows work with us. John, who's speaking today, is soon to be faculty member at UBC Okanagan. We've had a bunch of students come through, many of them going on to their PhD. And then at the end, these are some of the faculty members that are involved right now at Western and Laurier. We can move ahead, Leon. Just to give you an idea of kind of what we're doing on the research funding side of things, we're currently funded by the Canadian Payroll Association. They've committed $750,000 over 3 years, which is amazing, and allows us to pay people like Leon that are doing all these great things. We've got an alliance grant that's currently under review, and if everything goes according to plan, this could turn into a multi-million-dollar budget. So there's a lot that we could do. And it was originally funded by the Center for Quantitative Analysis and Modeling at Fields. So this grew, the Financial Wellness Lab grew out of one of the Fields-CFI labs, for those of you who are familiar with Fields-CFI. So I think this is a real success story here. We've got data access agreements with several industrial partners. Here they are. We've got a couple of papers published. We've got a couple more under review. We've made a bunch of presentations, the Academy for Financial Services, the Fields Quantitative Finance Seminar, Statistical Society of Canada, the SciM Financial Math Conference, and I'm going to hopefully get this right, John, the Certified Financial Planners Industry Group. And we had some good news. We just found out a couple of weeks ago that one of our papers won the Best Paper Award in Investments. That award is sponsored by Morningstar, and that's for a presentation we're going to be making at the Academy, the upcoming Academy of Financial Services meeting. So that's just sort of an overview of who we are and what we're doing. Like I said, we have 2 sort of big research themes. One is on resilience, financial well-being. The other one is on investment behaviors and how that can support good decision-making. And we're going to be talking about that investment behaviors project and everything it involved today. So I will turn it over to Leon. Before I do, I think I will do my best to sort of moderate. If people have questions, maybe we could type them into the chat, or we could raise our hand. And I'll do my best at trying to find a good time to interrupt Leon and address the questions. By all means, we want this to be interactive. We want people to ask questions. Don't hesitate. But if we could do it through the chat or through the raising hand feature, that would probably be best. And I'll turn it over to Leon now.
All right. Thank you very much, Adam. Good morning, everyone. My name is Leon, and I am the data engineer in the Financial Wellness Lab. So thank you for joining us here in this early morning. So next, I'm going to introduce the financial data set we have and walk you through the procedure of unsupervised learning technique. And finally, I'm going to show you how to implement data clustering method on financial data. More specifically, it's customer segmentation analysis. Yeah. So, okay, let's get started. So the data was collected from an investment dealer in Canada. So it's a private company. Recently, the company is facing a challenging environment in the market. So a new strategy was undertaken by the new management team. Around 2019, they started to try to become a more data-driven company. Now it is in the middle of the journey. So our lab is helping them understand their customer with data science tools. They didn't have anyone do that before. So yeah, and more important, our goal is not to replace advisors by machine learning tools, but to build a tool to assist advisors to serve customer better. Yeah. And our team is composed of data scientists and industrial experts. So usually we work together to understand the data and develop the problems to solve effectively. Yeah. So now let's dive into the data set we have. So the data set covers more than 31,000 clients with more than 80,000 accounts. And the reason why we have more accounts than clients is because a single client could have multiple accounts, right? Such as TFSA, RRSP, and non-registered accounts such as we call cash account, yeah, and so on. And we have 416 financial advisors serving the clients. And furthermore, we have more than 4.5 million of trading or transaction records over the 403 business days. And more specifically, we have the following data sets to describe the clients. The first one is KYC data set, which contains the general profile information for each client on a single day, such as age, gender, marital status, annual income, and investment knowledge level, and risk tolerance, and residency, and so on. So the profile data will repeat every day until they get updated when the clients meet the advisor to change their personal information, for example. Yeah. And the second data set is about trading equity, such as mutual funds and stocks, something like that. And the data set contains all the trades conducted in a single account for each client. This data set is relatively smaller than the others because if a client didn't make a trade at all, then we will not have any records for that client in the data, right? And the next, we have transaction data. This one is similar to trading data. It contains the cash flow going through an account for each client, such as an administration fee, dividends, deposits, cash withdrawal, and contribution, etc. And finally, we have portfolio data sets, which is a huge data set. It contains all the assets in a single account for each client on every day. So it also captures the daily market price changes for each asset. So you can imagine, say, if you have 7 mutual funds for 1 year, then the data set will have 7 records every day, but with different market prices. So this is only for a single client. So now we have more than 31,000 clients. So now you can imagine that why the data set is so huge, right? And okay, so since we have client ID, account ID in all data sets, so now I think some of you may have questions about the data security. And I can tell you that all the sensitive information has been anonymized, such as social insurance number, telephone number, postal code, the first name and the last name, and the bank account numbers. For example, the client ID is a 6 characters with letters and numbers, so which has no meaning at all. So this can make sure that anonymized data cannot be associated to any one individual. So yeah, they all have been anonymized by the company before sending it to us. So the company will keep a mapping sheet for the anonymized information. So this means only the company will know who is who and which is which, right? Yeah. So next, let's go through some parts of the summary plots, which can help us understand the demographic facts about the client. So the first pie chart shows the residency of all clients. Since the company's headquarters in Ontario, so you won't be surprised that the company has 66% Ontario clients and 14% from BC and 12% from Alberta. The interesting thing to know is, okay, if you Google Canadian population by province in Stat Canada, you will see the same ranking, like Ontario first, BC second, and the Alberta comes next, okay? And the second plot is an overlap histogram showing the distribution of ages for both genders. So here we have two perfect normal distributions. The shaded color in the common area for both gender is the overlap number. So if you see the yellow color or the orange color, that means we have a greater number of male than female. And if you see the blue color, that means we have a greater number of female than male customers. So overall, they have quite similar shape and statistics. So the average for all clients is around 58.7 years old, almost 59 years old. So yeah. And the second fact we can get from this plot is in the company, the number of male and female clients, they are almost 50-50, yeah. And the third plot shows how many retired customers for both genders. So we separate the frequency bars by genders, so you can compare the numbers between male and female. Both genders have similar number on retirement group and non-retirement group. You can see, okay. And second, for both genders, around 20% of clients have retired. So I think this makes sense to you guys, since normally the Canadian retirement age is around 65 years old. So by looking at the age distributions from the previous plots, we can expect around 20% of the clients have been retired, right? So yeah, so next plot shows the investment knowledge level of clients. So this was evaluated from the advisors when they did the KYC questionnaire. So you can see we have more female clients on the beginning level and the fair level. And we have more male customers on the good level than females. And for the excellent level, which is unusual in our data sets, but we still have more male clients than female as well. I remember there are some studies about investment behavior also reveal that the ladies are less confident about investing, and the male investors appear to be overconfident. And next is the income distribution in box plots. Okay, if you are familiar with box plots, the horizontal line in the color box is the median for the group, and the line on top is the maximum value, and the line at the bottom is the minimum value. So from this plot, the median income of male is more than females, and also the maximum income of male customer is far more than females. Okay. And the last plot on this page tells us, okay, how many active accounts for all clients. So the cash account is in the non-registered account, and the RSP is the registered retirement saving plan, and TFSA means tax saving accounts. So I'm not sure if you guys are familiar with those terminology. Like RSP is similar to the 401k in America. And also RSP and TFSA, if you have them, you will get a tax shelter, right? And for the non-registered accounts, you won't get any tax benefit. You're gonna pay tax for any dollar you earn from the investment. And also for the RIF is a retirement income fund. So you need to convert your RSP to RIF after retirement. And RESP is short for Registered Education Saving Plans. So if you start a family and you have kids, so you will save money for kids in that account, something like that. And yeah, so the top three are non-registered account, RSP, and TFSA. So most of the clients could have a combination of these three accounts. I'm going to tell you in the next slide. And the RIF comes next. And finally, we have a small number of margin accounts. Those accounts usually are trading with high risk equity. And also those clients holding the margin account will have kind of excellent investment skill. Yeah. So any questions for this page?
I'll ask a question, Leon, just for everybody's benefit. So the investment knowledge level, is that like somebody fills out a test and they get an objective score, or is that the advisor has a conversation with the individual and then sort of comes up with their own assessment of what their knowledge is?
Yeah, it was from the conversation. So the advisor will make a judgment on you or something like that. Yeah.
Okay, so they'll ask
Yeah.
you a bunch of questions, and then based on your answers, they'll
Oh yeah,
give you
exactly.
one of those
Yeah.
4 bins.
Mhm.
Okay.
Yeah. Okay, let's move on. So by now, you may have a general idea about the client from the company. So here, let's investigate more details about account. So the summarized statistics tells us a single client could have 1.9 accounts on average. And basically, most of the clients could have like 1 or 3 or 1, 2, 3 accounts, something like that. And yeah, and next is the intersection plot for the account holdings. So the first part of this plot is the frequency plot, telling us how many clients in each bucket. And the second plot, the second part of the plot is the combination of different account types. You can see those black dots indicate a yes in that account. So in the first bucket, we can see there are more than 4,400 clients have a combination of TFSA and RSP and non-registered accounts. And oh, just a reminder for you guys, this plot only shows the top 20 rank of the frequency for the account holding combination. So yeah, the number after 135 will get cut off. So now you can have a better understanding for the account holding in that company. So next is the advisor information. So from the statistical number in the chart, we know that an advisor has 72 clients on average, but the minimum is 1 and the maximum is 842, which is interesting. So it is unusual to have that number. You may have a question about how can a people deal with 800 clients in their account, right? So that's one reason, could be like an advisor can take care of a whole institution for many clients. Then he can make portfolio adjustment for multiple accounts at once, right? So that's why some advisors, the number can be so high. And in typical business sense, around 30 to 70 could be a normal number. Yeah. And I have one plot about the top 20 advisors. So you can see the first ID called AAAI is that champion who has 842 clients. And the advisor IDs have been anonymized, so you won't get the name for that advisor. And one more interesting finding from the plot is that, okay, there's no gender preference for those advisors. So the percentage for male and female clients are still 50-50. Okay. And now let's look at the product details in that company. Overall, the main product is mutual funds, as you can see. So the mutual funds with low to medium and medium risk level. And more than 50 of the products are mutual funds. So, but also we have a relatively small portion of GIC in low risk. GIC is a low risk instrument. So it's an investment guarantee 100% of your original money. And also you can earn certain amount of interest in a fixed rate, sometimes at a variable rate. Yeah. So also we have a small portion of common stock with high risk. Yeah. And the plot on the right shows the dollar amount for each category in client's account. So yeah, which is surprising, or maybe not surprising to you guys. Around 80% of the money goes into mutual funds. And the reason why mutual funds are so popular is because it offers a wide range for investors to choose from, and it is managed, right? And it is good for different investment goals for different people. For example, if you are conservative and looking for some stable incomes, and then you can find a mutual funds that fits your need. And if you are an aggressive person instead, you can still find in a mutual funds that can achieve the similar targets as buying a stock. So yeah. And here's another reason. In the company, most of the financial advisors, they only get the license to trade mutual funds or some other limited financial instruments. So yeah, that's the other reason why mutual funds are so popular. Okay. Any questions by now? Okay, let's move on. So now we have these 4 data sets, and the first project we need to do is to explore the customer segmentation using the unsupervised learning techniques. So then we will go further to find interesting patterns from the behavioral data. So in the next couple slides, please allow me to introduce the basic concepts for unsupervised learning and clustering and customer segmentation. Oh, sorry. Okay, so suppose you get a couple of big data sets, say 100,000 of clients with millions of transactions, right? So you always want to know the basic structure of the data in a data-driven way. And you may want to know what is the common characteristics of the client, right? Or if you are the person who running the business, you may want to confirm or validate some marketing strategies in your mind. Then unsupervised learning technique is your choice. So it allows you to know the data quickly and help you find some patterns based on the variables. There are some successful applications in different areas, such as news section. For example, the technique can categorize the articles from Twitter or Facebook, right? In the field of computer vision, it can be used for object detection or pattern recognition. And in anomaly detection, it can be used to discover the atypical data in the data sets. So since some unsupervised learning technique is quite sensitive to outliers, so we can use it to do the anomaly detection. And for the customer segmentation, which is what we are doing, so it can help us understand the client's trading habits, right? And finally, if you need to build a recommendation system, you also need to cluster your clients or your users before recommending. And then we know that users in a cluster will have similar interests, and then a product will be selected, will be suitable to that target user, right? So yeah, as this picture indicates, after we get something from the model, we still need to do the manual checking to make sure the result makes sense in business world. And then our people will interpret the findings in a business language into a product. Yeah. And clustering is the most common unsupervised learning model. So when people talk about unsupervised learning, you should know they are talking about clustering. And clustering algorithm separates the input data into groups using the similarities or distance metrics such as Euclidean distance. And a cluster is often a group of data points in the feature space. Usually they share the common characteristics. In plain language, I would say, and they look similar. So yeah, so the cluster may have a center, or they may have a boundary or extends. Yeah, it depends on the data. And there are many clustering algorithms to choose from, and no single best clustering algorithm for all cases. So instead, it will be a good idea to explore a range of cluster algorithms and choose the best one fitting your data set. Yeah. And there are many categories of clustering algorithms. So, machine learning is a hot topic these days. People never stop creating the new algorithms. So here I will introduce 3 popular ones for you. The first one is K-means. I think this is the most popular algorithms in the machine learning world. Yeah, and K-means will set up a few cluster centroids, and then it allocates each candidate data to the nearest cluster. And say we are using the Euclidean distance. If the data has the smallest distance to the blue centroid, yeah, it will be colored as a blue member in that group. And then the second algorithm is a hierarchical based clustering. So we call BERT. It uses a tree structure summary to create a clusters. So when you load the data into the model, it will resize the data for better fitting into the tree. And then if the tree satisfies a threshold, then it will split into a subclusters, which will be cleaner and smaller. Finally, you will get the tree to represent the data groups. And the last one, but not least, and is the density-based clustering we call DB-scan. It is useful when you have some interesting data distribution. So first, it will look for the core data points in crowded region. And then it will keep expanding around the space and try to find the neighbors with certain distance. If it finds more than 3 neighbors, for example, 3 neighbors at once, it will continue to search. So in this plot to the right here, if we only use K-means, you will only get half of the circle with the same color. But for DB-scan, you will get a full circle with the same label color, which is what we need. And next, our question will be like how to evaluate a clustering model and how do we know if the model is a good one or not. I would say evaluating the clustering model sometimes will be a tricky task compared to supervised learning. And we have 2 data-driven approaches here. The first one is elbow method. Usually the within cluster sum of square error will decrease when the cluster number increases. So after a particular point, the arrow starts to be flattened. This is the elbow point. And we can pick that number as the optimal number. The elbow rule is quite intuitive, right? And sometimes the elbow point is not easy to observe. It's not obvious. Then we have the second method called silhouette score or silhouette metric, which is more mathematical. It calculates the ratio between within cluster distance and between cluster distance. So if the ratio is positively high, that means we could have a good separation on data. Yeah, this method is more reliable than elbow curve, as you can see here. And since the real world data is always complicated, sometimes the mathematical evaluation doesn't give you a clear decision on how many clusters you should have. So in this case, you can ask industrial experts for help. So experts can have domain knowledge. They could give some prior knowledge on finding the number of clusters we need. Yeah, so yeah, and at the end of the day, the industrial expert will be able to find the connection between clustering and the real world business. And those findings could be useful. And those are the model makers like me wouldn't notice before. Yeah. So again, it's important to know that the data scientists should work with a team. Yeah.
I'll just jump in and corroborate that, Leon. Sorry to interrupt, but it would be impossible to do what we're doing without talking to, people who are experts in financial planning and them giving us feedback if what we're seeing kind of has meaning. And it's a really sort of, I would say, an interesting and exciting challenge to be able to try and communicate some of these complicated ideas and what we're trying to do to people that are not necessarily thinking about math all the time, and them also trying to communicate to us. It's a really interesting back and forth, and I'm really enjoying it. So both sides of the equation here are essential, right? The domain knowledge and the data scientist. Sorry, Leon, go ahead.
Yeah, so we can use their knowledge to analyze the data. And also in the real world, we always try to use business language, like, okay, do not show the formula, use the number and plots to speak. Yeah. I see one hands up. Any question about this?
Yeah, I had a quick question, Leon. It's actually about the previous slide where you had the number of cluster rule, this elbow rule. Is there some underlying probabilistic underpinning for why one would do this?
This is a intuitive method. Yeah. So usually the clustering will separate the data into smaller group if you don't tell them how many clusters, right? So they're gonna continue to do that. So you need to set up a rule. Okay, so if we have more clusters, but those outcome didn't add too much value on clustering, and then we will stop. Yeah.
Right. Well, I was thinking of, in the line of like Bayesian information criterion, when you have underlying, when you're doing model selection, there's a probabilistic underpinning as to why I do that, right? You put a prior on models, and then you get the posterior based on the estimates, and this is approximately equal to this log likelihood plus this this penalty for number of parameters and number of data points. So I was wondering if there's something like that underlies this rule, or is it really just ad hoc? Ad hoc in the sense that, yes, it's trying to balance two things in a manner, but yeah. So
yeah.
Any insights there?
Yeah. Usually, yeah. You just eyeballs them, and then I would tell you, okay, most of the time the elbow rule didn't work, and then you have to go to the step 2, use the silhouette magic. Yeah.
So it's one of many things you might want to look at. I'd say, Sebastian, to answer your question, pretty much it's ad hoc. If you wanted to draw a parallel to something, it'd be maybe like an R² or something like that, but beyond that, there's nothing much more sophisticated than that.
Okay, thanks.
Yeah.
Thank you for the question. Good question.
Thank you. Yeah, good question.
Anybody else with questions, don't hesitate to ask.
So I guess let's move on. And the picture you are looking at here is the map you need to travel with if you are doing the clustering analysis. So first, we need to make sure the data is in high quality, right? And when combining multiple data sources, there are many opportunities for the data to be duplicated and also mislabeled. So when you combine many CSV files, sometimes some of them could have the same data, but with different names. So be careful with that. And also sometimes we have the interesting entries that comes outside the dictionary because some data was entered manually. There could be all kinds of typos. For example, we have a column called occupation. So people can enter their job title with a 10-character space. So then you can guess some people, they can sing and dance with the 10 characters, right? So they can type anything. So I would say we spend 70 or 80% of our time on cleaning the data and think about how to create features. Yeah. So the red pathway in the red color, you can see here, is painful. And the green pathway is not. Yeah. So you will have fun after the data is cleaned and feature engineering work is done. Yeah. So for the rest of the time, the clustering algorithm can help us understand the data quickly. So I guess this is the advantages of machine learning. So you don't have to look at a couple 100,000 of clients again and again by your eyes. The algorithm can do it for you. Yeah. So next, my colleague, John Thompson, will walk you through some feature engineering work we have done. So John, I'm gonna pass the microphone to you.
Thanks, Leon. We'll be continuing on with discussing feature engineering. And feature engineering is, in some circles, you might call it something else, like thinking about statistics that you might use in your model or different inputs into your model. But in machine learning, it's typically called feature engineering, because usually you're processing the data into something that you can use as an input to some, say, clustering algorithm. And the first thing before you ever decide, say, hey, I'm going to calculate your age, say, from your birthday, first you have to ask yourself, is the data source that I'm getting, and is my data very good? And if you don't, and one of the keys to effective feature engineering is knowing your data. And before you start any modeling, you should really understand your data. And I'll give you an interesting example. Since I've got a little bit of time here, I can kind of wax poetic about it. I have a colleague who was working on a project. He was working on this project. This is Dr. Devin Becker at the University of Western Ontario. He was working on this project with a company out west, where they were studying pilot fatigue in forest fire pilots' flight data. And so he had the angle at which the plane took off, every time the plane took off, the angle at which it was, the height in the air it was flying at, the path it went, how it dipped down, picked up water, picked it up, went over to the forest fire, dropped the water on, and then repeated that path, 8 or 9 times, and then went back and landed at the airport. And he had this data for all this, for all these pilots, for all these different forest fires. And he was charged with the task of trying to discover pilot fatigue in this data. And so you could think, oh, if you have certain variation around the path that they're taking, maybe their takeoff angle, their landing angle, we'd be able to measure fatigue. And as he studied the data and he was working really hard with it and working really closely with the partner who was interested in this, they were having a lot of difficulty finding any evidence of fatigue. Didn't really matter what model they were using. I suggested some models at the time, and those were just as useless as the ones that he was trying to, if not more useless at the time, trying to figure out what his problem was. And then he realized after a discussion, and this is about 6 months into the project, they were discussing this with the industry experts, and the industry experts they're like, we know what the rules are, but how are you actually implementing the rules around how often a pilot can fly in a forest fire? And it turns out that, there was regulations in place, and they were like half the regulations. So if you were only allowed to fly, like, say, 4 times a week, they were only doing 2 times a week or less. Like, they were like way under what they were supposed to be, which was the limit. So they're being very careful. Turns out, that ensures that pilots aren't being fatigued, and actually you could probably push them a little bit further. But, he thought, what he had found, he didn't really understand his data. And it wasn't because of the fact that he didn't know what the regulations were. It's because there was something in the data generating process being influenced by the people who were in charge of the pilots that they didn't know, and they hadn't told him in advance, right, for 6 months. And so really, I thought it ended up being a very interesting project. He had some interesting results, but it was really a quote unquote non-result. Oh, sorry, that's not a question. It's just
you have a delivery? Oh, okay. Yeah, I'll get a ping.
Thank you. So that's the key into understanding your data and your data source. So engage your creators, engage the collectors, engage the processors we had a similar experience, but more of a, oh, that's, you know, a piece of data that we were missing. We were discussing this with some of the compliance officers at our private investment dealership. And we started talking to them about the financial advisors. And then the topic of license and what the financial advisors were allowed to distribute. For example, Leon mentioned earlier, they could only, you know, sell or trade in mutual fund products. One of the things that came up was that financial advisors have a specific types of licenses. So one kind of license is a discretionary license where the financial advisor could have full control of the client's accounts, make trades on the clients, and the client, you know, when they set up the account, they sign off that the financial advisors can do this. Or you can have the situation where it's non-discretionary, where the financial advisor can make trades, but only with permission from the client. And the client would want to make trades, but he has to contact his financial advisor before he makes that trade. And so there's different types of licenses. And this was like, oh, this is interesting. We didn't have this data before. It's not in a huge data set that they gave us. And we actually realized in partnership with the private investment dealership that this is an important thing for us to know, because we need to know how the data is being generated, because there might be some underlying effects that are happening that look like something interesting or don't look like something interesting, but there actually is something going on or not. And so that's why I say, you know, engage your subject matter experts and integrate their knowledge. You know, working with Chuck Grace for the entire time of our project has been really interesting, because we have learned so much in the last for me in the last 2.5 years. I think Leon's been about the same amount of time and working together. And, you know, immersing ourselves in the subject matter, I, you know, have learned, you know, a vast amount in finance to add to my statistical knowledge, and being able to, you know, combine the two and integrate them. So in the bottom right, you'll see a picture from Moneyball, where it's the GM of the baseball team and the statistician who's sort of working together to create these metrics and understand, you know, how could we, you know, build the best team that we could possibly have with specialists in certain areas, which we would use them in certain parts of the game, and what statistics can support us, right? It's a combination of subject matter expert and statistician or machine learner. So next slide if you could, Leon. So in our case, a subject matter model that we applied was the recency frequency monetary models that is typically used by marketing firms or commercial businesses to analyze customer purchasing behaviors. And the RFM, so the recency is, you know, the recency of your last purchase. So in a company where, you know, you're monitoring what people are buying from you, say you're selling t-shirts, when was the last time this client who's purchased t-shirts from us before, you know, when was the last time they purchased it? A week ago, yesterday, you know, they've only purchased from us once. And so when I say only purchased from us once, that also brings up the idea of frequency of their purchases. So are you purchasing, you know, are you purchasing once a month? Are you buying a t-shirt every month? Are you buying it just like 5 t-shirts once, you know, a really long time ago? And then you never interacted with us since. And what is the monetary value? So what's the size of each purchase? Are you buying 5 t-shirts that are really expensive, 1 t-shirt that's really expensive, or, you know, it's, you know, there's different ways you can even quantify what monetary value means for each purchase. And so this has been used before in data mining algorithms. And so it's using subject matter models, adapting them to your problem, which our problem is trades and transactions in finance, and then using those features that we generate from those models in machine learning algorithms. In 2019, and Ethan Patel also did this in a totally different context, not in finance, but, you know, we can use these ideas and use these subject matter models in our feature engineering to generate features that are interesting and useful that we can cluster on to measure the things that we want. And what we want to measure is financial behaviors. Thank you, Leon. And so we are able to kind of measure these financial behaviors through these types of models, because now we have, you know, what are your behaviors in your trading? And so for recency, we use number of days since your last trade on record. Your frequency is your total number of trades. Also, we looked at average number of days between trades. Those are highly related. So, you know, we ended up using one or the other in our final models. In the monetary, we had a lot of different types here. We have buy and sell size totals. And so, you know, we look at the entirety in which we have your data. If you've purchased, you know, how much total have you purchased? How much sell have you conducted? But then we also had another part of our monetary, which is another feature that we engineered, which is trade size by type. And there's 3 trade types, and they're sort of classified using the subject matter model with the financial expertise of our partner, Chuck Grace, who's our current project manager. And, long conversations, and this happened mostly between Leon and Chuck. And then once they had a good idea of what they wanted to do, we kind of all sat down together and worked on it together. And this is what we ended up coming up with, is a third-party trade type, which is a, third-party initiated, which means, if I purchase a mutual fund, it'll pay a dividend, and that dividend paid to me in cash is initiated by the third party, which is the mutual fund. Anything that's not the financial advisor and not the client, so not the account holder, if it's initiated outside, then that's considered a third party. And these are the 3 trade types that we have for that. And systematic is initiated by the client or the advisor, but it's periodic. And I guess this is where I might confuse you later with periodic trade types. In mathematics, we say periodic, we say it's happening with a certain periodicity. So auto withdrawal for me, say I contribute $100 to my TFSA every month, right? That's a auto withdrawal in which that is, automatically withdrawn from my account. I'll pay some fines if I don't do that. Or I don't have the money ready for that, but that's just an example. And then there's the periodic trade type, which in the industry of finance, you say periodic, but in the mathematical world, you might say aperiodic. So it's those, random buy, not random, but, unplanned or unscheduled buys and sells, withdrawals, anything like that. So that's your typical trading. And so that covers all the 3 types of these that we're thinking of. But then we added on an extra, which was the profile. And the profile here is just who you are as an individual, your age, which we calculated from your birthday, your gender, which is already right there for you, your residency, annual income, investment knowledge. There's interesting things about investment knowledge, right? We saw some of those effects in those graphs earlier. Think about the number of accounts you have. That's not something that we're given. That's something we had to engineer. Right? If you have 10 accounts, you're much different than someone who has 1 or 2, right? And so we wanted to add those into our clustering algorithm because it really, we're trying to see what your behaviors are like and how people clustered in their behaviors, which Leon will talk about next. And so I think I'll pass it over to Leon. I think you're going to be talking about feature scaling. So go ahead, Leon.
Thank you very much, John. So yeah, so suppose you have all the features or variables ready. So we need to do the feature scaling before we feed them into the clustering model. This step is actually quite necessary because those variables could have different scales, such as trading frequency has a range from 0 to 50 or 100. Right? But the trading amount has a range from $0 to $1 million, for example. Yeah, so most of those clustering algorithms, they are quite sensitive to the magnitude of the variables. So if I don't scale those variables, probably the model will focus on the trading amounts only. So to avoid this kind of issue, we need to let the model to treat all those variables equally, right? So suppose I have these 2 variables. One has pretty long tail distribution, and the other one has a few very large outliers. So let's make scatter plots to see what kind of issues we may have and what scalars are available for us to solve this problem. Okay, so there are many scalars available if you Google them. So on this page, I list out 4 of them, which people often use in data pre-processing. So for the log transformer, we can see it only works with non-zero data. So since our data set could have many 0 values, such as trading frequency, transaction amounts, periodic trade, something. Yeah, so the log transformer might not be a good choice for us here. And for the min-max scalar, it is sensitive to the outliers because it uses the minimum and maximum to compute. Yeah. So when we consider variables such as trading amounts or income, which always have outliers and long tail distribution, it will compress many inliers into a small range, which could be a problem for the clustering model. So min-max scalar is not a good choice either. So in the next slide, I will compare the standardization and power transformer in the real world application. So you will see how many different they scale the data. And then we will choose the best one which fits the model. Okay. So the first scatter plot shows the data with no transformer. So we can see a large majority of the data is compacted to a specific range in both directions. And the second plot shows the standardized data. We can see the outliers still have a strong influence when computing the average and standard deviation, right? So the data still gets squeezed into a small range from 0 to 70 for y-axis and 0 to 15 for x-axis. So if we apply clustering algorithm on this data, the model will have trouble on separation. So it will get confused and could give us a big single cluster at the end, which can be misleading. So in this case, standardization cannot guarantee balanced feature scales if we have outliers or big outliers. And the third plot tells us, okay, the power transformer can do a better job and give us more stable variance. So in this case, it will make cluster easier to distinguish the groups, even though we still have the outliers. We still have the outliers in the plot, right? But we can control them into a acceptable range. So the outliers never go away. They still skew the data, but we can control them. Yeah. Any questions on here?
Leon, it looks like Sebastian has a question. What about log 1 plus x?
Log plus s, it's a good idea, but I think in our experiment, we still cannot get a Gaussian-like distribution after transformation. Yeah.
So it could be context dependent, maybe.
Yeah. Yeah. Okay, let's move on. So a moment ago, we talked about feature scaling, which can change the range of input variables. So now another technique is called dimensionality reduction. Is also important. It helps us understand the structure of the data in a simple way. So for example, we have 7 variables here. All of them are trading behavioral variables. So usually for data visualization, it's okay to plot them one by one, right? And even do the scatter plot for a pair of the variables. But what if we want to see all variables at once in a 2D or 3D graph? So the dimensionality reduction technique can transform all the variables from a high dimensional space into a low dimensional space, so that we can visualize the low dimensional representation in a 2D or 3D plot. So by using this technique, we can still retain the meaningful property from the original data. So yeah, here I will introduce 3-dimension reduction techniques. The first one is PCA, which is the most widely used in machine learning in many data sets. So it is fast and easy to use. And the output of PCA is called principal component. They are a set of new variables. So they are constructed as linear combination of the original variables. So in such a way, PCA performs a linear mapping of the original data to a lower dimensional space. And the second one is called TriMap. It's an advanced DR technique. It uses the triplets, i.e. a set of 3 data points. So it uses triplets to simulate the distance of high dimensional space. So in low dimensional space, the triplet can maintain the distance of the original data quite well. So yeah, so this method is still fast, but a little bit slower than PCA. We will have comparison in the next couple slides. Yeah. And the last one is TSNE, which is a superstar in dimension reduction area. So it creates another distribution which can map the high dimensional data into low dimensional data based on probability. Okay. And this technique can give you a good 2D or 3D visualization, but it is also a computationally intensive algorithm. Why? Why is intensive? Because the distance is computed. The distance from TSNE is called relative distance, and it is computed based on conditional probabilities for all other data points. So yeah, again, at the end of the day, there's no way to map the high dimensional data into low dimension and maintain the whole structure 100%. So there is always a trade-off for those techniques. So yeah, so if you use DR on your original data, you always lose some information. They can be noise or they can be useful, right? So the good thing is, okay, you can visualize all your data in one plot, in one picture, right? So yeah, next, I will show you the 2D and 3D visualization for trading behavioral data, trading behavioral variables, okay? And let's look at the PCA 2D plot here. So it takes only 2.7 seconds to run only. It is a fast algorithm. And we can see there is a group of data points on the left side, but it is a little bit difficult to see groups on the right side. Right? It looks like a trefoil logo from Adidas. So in this case, PCA is not doing a really good job in 2D visualization. And the second one is from TriMap. It's not bad. It takes 40 seconds to run, right? Not too bad. And this plot looks a little bit like PCA. And the data points are closer within the same group. So we can see that some data points are spreading out of the group here. So this could be the outliers on some variables. And the last plot is from TSNE. And you can see it is a intensive algorithm, which takes more than 7 minutes to run. So yeah, compared to PCA and TriMap. So from this plot, you can also see a clear boundary for each group, and the data points stay together in a quiet descent weight, right? So now we use the same set of behavioral variable on trading data. So, and then I will feed them into clustering algorithm. I use k-means here for demonstration. So the evaluation plot tells us 4 clusters could be the best option for now. And oh, I would like to make one clarification here. The data we use for clustering is not the outputs from dimension reduction. So we use the original data for clustering. Then we can attach the cluster label with different color to the data. It sounds like a 2-step verification. And we use the original data twice. And then we combine the 2D plot and the cluster labels. So if they fit quite well, then we are confident that we find the patterns from the raw data. And the reason why I don't recommend clustering with dimension reduction outputs, it could be like sometimes 2D representation cannot contain everything from the original information, right? So we want the clustering algorithm to learn as much as possible so that we can make sure we won't lose some potential or useful information. Okay, so this is the clustering label on all 2D plots. So you can see after labeling the data points, you can see the groups more obviously. We can also confirm that there exist some distinct groups of the clients with different behavioral patterns. So especially for the second plot, you can still spot some green points, green data points in the brown group or the red group here. So since we use the original data as input for clustering algorithm, so the k-means will separate the data in high dimensional space for sure. So this 2D plot cannot show you what's going on in higher dimensional space. Yeah. So same thing for TSNE 2D plots. You can see the green points on the red and brown cluster here. For now, I think we discussed enough for 2D plots. So let's see what happened in 3D. Before we go to 3D, any question?
We've got one, Leon. Clinton would like to know what was the metric used to evaluate the k-means clustering?
Oh, we used Euclidean distance.
Okay. Does that answer your question, Clinton? Did you have any follow-ups? Wondering why we chose
I
that?
was just curious because like some of the categories had very like categorical like data because they were just integers, right? But yeah,
Actually, we are using the 7 variables. They are all numeric variables. So here I use trading behavioral variables for demonstration. We didn't use all variables here.
So that's a really good question. We've got all this data available to us, but we can't feed it all into the algorithm because it's too much. And so we had to make some choices about, okay, we'll feed these things into the clustering algorithm, and then we'll look, you know, in order to understand the clusters, we'll look at some of these other variables that we didn't necessarily feed in. Is that fair to say, Leon? And does that help Clinton?
yes, it does.
Yeah, okay, that's a good point. And this is something I'm sort of jumping ahead, but yeah, thinking about how to do the distances and stuff like that when we're doing survey data where everything's either ordinal or categorical, you have mixed data types, is a real problem. So thank you for the question, and I'll get out of your way, Leon.
Okay. So let's go to the 3D space. So in the 3D space, we can see for PCA, we can see the brown cluster stays higher than the red and green. The red cluster is in the middle and the green cluster is at the bottom, right? So if you look at them from different angle, you can see those clusters do not have too many overlaps than we thought in 2D. So yeah, and the second plot is TriMap 3D. I think this one is quite straightforward. We can still observe 4 distinct groups of data points for different colors. Yeah. And the last one is TSNE 3D. Okay. Personally, I enjoy watching these 3D plots. It looks like a human brain, and then you can find those grouping boundaries by rotate the plot. Say, okay, the brown cluster, and the green cluster, and yeah, and the purple, and so on. And a small tip over here. So if you would like to generate a 3D plot from TSNE, you must be patient since it's really intensive. So in this experiment, it takes 23 minutes to generate such a plot. So while PCA and TriMap, they are still fast for 3D. Okay, so yeah, it really depends like what you want. And here is the summary table from k-means cluster. And the numbers are within cluster average. So you may notice that I put age and income on the list, even though I didn't use them in trading behavioral data clustering. I put them here for further comparison, and also we can use those to profile the clients with more details. So yeah. So cluster number 1, those clients are active investors because they have highest trading frequency, 10.9, and trading amounts in buy and sell. And those amounts are quite huge compared to other clusters, right? And you can see they have solid income and focus on their saving since they have large amount in systematic transaction. Systematic transaction, or sometimes, okay, it contains the PAC, pre-authorized contribution, and yeah, it means you have some saving action in that variable, right? And clients in cluster number 4 are considerably less active. They have 0 value in trading frequency, so they didn't trade at all, but they have little saving transactions on their accounts. And cluster number 3, you can see they are older investor with high saving transaction amounts. What makes them so different is that they tend to sell other than buy assets. Okay. And cluster number 2, they are wealthy clients. They have the highest annual income. They tend to buy more assets, right, during the period. Yeah. So yes. So basically, to summary what we just found. So the cluster 1, they are active rebalancer who have large income and trade frequently with largest buy sell amounts. They have large amounts in regular saving transactions. And cluster number 2, they are young wealthy investor, but not strong saver, and they trade occasionally with large buying and small selling amounts. And cluster number 3, old investors with high saving transaction amounts. They trade occasionally with big selling amounts. Okay. And cluster number 4, they are kind of zombie with solid income, but they take no action during the period and appear to maintain their systematic saving transactions. Yeah. So this is what we get from the trading behavior variable in clustering. And once again, there's no limit for feature engineering. And for now, I hope you all can get a general idea that how to use clustering to find behavioral patterns for the customers in your project. Yeah. So thank you for staying here. And next, I'm gonna pass the microphone to John again.
Thank you, Leon. I found that really interesting, and what's interesting about the models that you showed today, they're very much a result of a lot of different models that you have worked on over the last couple of years, even from the paper that we published in January, where we were using these types of models. What we found in that paper is a lot of the categorical information, such as, if you're retired or not, your marital status really didn't inform what your behaviors were going to be. And really, we could tell a lot of your behaviors by mostly looking at your behavioral data. The only piece of information that was helpful from your profile was your age, and only one cluster we were looking at, and it was the cluster of older individuals who were close to or in retirement, was significant. And it wasn't even in that cluster. There was lots of individuals across the way, so it wasn't like a significant difference in the distribution after a couple of tests that we ran. So we thought that was pretty interesting, but we still incorporated that as sort of the name for that cluster. I'll be talking a little bit about that at the end of this portion. So what I'm going to talk about is kind of switching gears a little bit and more getting back to the finance side of things and thinking about finance resiliency and talking a little bit about that, but talking about how we use financial ideas in our industry applications, how we use concepts to be able to come up with metrics to be able to study clients better and understand how they are behaving. And so typically when you go to open an investment account, when you open those investment accounts, in Canada, you sit down with a financial advisor in person. They ask you a bunch of questions. They find out what your financial knowledge is. They find out, how old you are. They ask you for your SIN information. They get all this data from you. One, is to be able to do fraud detection, just to make sure you are who you say you are. There's no insider trading going on. Like, are you working for a certain company in which you're going to be trading with? They need to have all that information, and that's part of the Know Your Client regulations. But what they also do is they're trying to measure your risk tolerance. They're trying to see what kind of account is going to be appropriate for you. Are you close to retirement? Are you saving long term for your retirement? Do you have kids to save for? Are you going to buy a house soon? All those different questions. And then they select and help you manage those investments based off that conversation. So that onboarding understands your investment objectives. And then the advisor says, here's some products that we think are good for you, right? And the Ontario Securities Commission, regulates that. Like we mentioned, Know Your Client many times, but they also regulate through Know Your Product. And so you need to know what you're buying, what's contained within it, how old the investment is. And really the biggest question is the riskiness of that product. So if a stock is low risk, if a mutual fund is high risk, what does that mean? What does that mean to the investor? And so your private investment dealership has to come up with ratings for all of your different products. And they also have to have an understanding of the risk of all the different clients. So we've sort of talked about two types of risk here. And if you can go to the next slide, Leon, that'd be great. You can either have, what I've mentioned so far is two types of risks, right? And one, we talked about elicited preferences, and those are what people say they like. And then there's the revealed preferences and what people actually like. So you can tell me, John, I really like t-shirts that, I only like white and black t-shirts. And then you go out and you purchase a blue t-shirt. It's like, well, you said you like this, but you're actually buying things that you like, right? And that doesn't really line up with what you said, or maybe that is lining with what you said. In the same vein, that initial meeting with your financial advisor, when you set up your, you get all that KYC information together and you say, oh, I'm not a really risky guy. I don't really like to buy high risk assets. I'm trying to save, for long term, but I don't want to put myself into a position where I might lose a bunch of money at a certain point. And then you say that, and then you go and start trading, and you're trading GME stocks and cryptocurrencies. And you're like, oh, but that's not really high risk to me. It's like, well, it's very high risk, and we told you that was high risk, and you're not really lining up with what you said, right? And so there's an issue there, and then you have to have those conversations between the financial advisor and the client. And so that's what we're trying to do here, is measure the difference between what you say you like, or what you say your risk tolerance is, and what your actual risk tolerance is. And the advisor sort of acts as a black box for both of those, because through those conversations in our data set, the advisor comes up with a risk rating. It's partially through a questionnaire, which you get a risk rating through that, but then the advisor can massage that and change that, and then give a final risk suggestion. And then through the revealed preferences, well, as a financial advisor, I'd say, hey, you should go out and trade these mutual funds, right? And so you say, okay, my financial advisor told me to do that, I should go trade, but look at all the different mutual funds he suggested, and that actually guides my risk as well. Right, if you think about that. So there's a lot of interaction between a client and advisor here. It's really something that we're trying to understand at the Financial Wellness Lab. And we feel like we've actually got some really good ideas around it. So if you go to the next slide there, Leon. And so in our data set, we looked at our data, and we found, it turns out, we had 5 risk categories for products. So each product is either given a low, medium, medium high, or high risk. Right? It's 5 categories. And so the elicited risk is given by the financial advisor. You as the individual, you go and you meet, you write out that questionnaire. The financial advisor analyzes the questionnaire using a sum score. They give a score out of it, and then they talk with you and say, okay, we think your risk is about here. So I'm going to suggest to you is you should put 50% of your assets in low, medium, and 50% of your assets in medium. And this is the profile I think would work for you in your life situation right now. And you say, okay, yep, thank you. That's a really good suggestion. You go out and you start trading. The advisor select products, you select products, you buy those products with approval. And you end up with a maybe not exactly equivalent to your original distribution. So the advisor, so you end up with 23% and 76%, low, medium account. And so you ask yourself, okay, John, how do we compare those two, right? there's many ways to carry it. So we asked, how do we measure risk within that portfolio to say what kind of risk it is? So you could probably immediately look at these distributions and come up with a single number in your own method. But we tried a lot of different methods. And if you go to the next slide there, Leon, and how to be able to measure and then compare them. We tried F-divergences, so you probably recognize a lot of the names if you're a mathematician on this. We looked at the total variational distance, Euclidean distance. We even came up with our own in-house financial wellness lab discrepancy metric methodology that we spent quite a bit of time on. And so what's similar about all of these is that you compare those two distributions, right? You compare each of those categories, and then you summarize the comparison of those categories. So that's what I mean by compare and then evaluate using these methodologies. When we evaluate and compare, then we evaluate, the elicited separate from the evaluation of the revealed risk, give a number to it, and then compare those two numbers. And so that's what I mean by evaluate and compare in that situation. And we tried all these different methods, The easiest one was probably the Likert, the raw one for evaluate and compare, which was a little bit useful. A lot of them didn't really capture directionality of saying if you're over risked or under risked. That was a big problem with most of them. That's what we tried to solve with our in-house methodology. It didn't work as well as a financial methodology that we ended up working with. So if you go to the next iteration of this slide there, we ended up using the value at risk methodology, which is a well-known methodology in finance. And so next, what I'll do is I'll describe that methodology, show you some of the results, and then talk about what are the advantages and the disadvantages are. And so the value at risk is a quantile for the profit and loss distribution. It's for example, in our work, we looked at what's going to be your minimum loss on your worst day out of 100. So that's a 99% quantile. And what that means is on the worst day, you could lose, say you have a $10,000 total investment. See, that's your total wealth. On your worst day out of 100, right, you might lose $1,000 or more. And so your value at risk would be 10% or 10,000 basis points. And so, no, 1,000 basis points, sorry. So 1,000 basis points, you move the decimal place twice, you get the percentage. So it'd be 10%. And so that would be your value at risk. And so this was an interesting task for us. And in this formula, we could see all the different possible ways you could set it up. You'll notice that there's a mean daily return vector and a covariance matrix for categories. And so, if you have a profile, I can tell you if I know what your daily return is for the last 100 years, I can give you a value at risk at today of what what we think your daily return vector on any given day is. I can tell you its covariance with all the other assets in your profile, right? So I can use any of your assets. So your assets are located in vector X. But the problem with that is, okay, so how do you evaluate an elicited risk tolerance, say, before you even have a portfolio? How do we come up with a way to evaluate your elicited risk when you don't have any assets that I can base your value at risk on? And so we thought about this. Actually, I think it was Adam that came up with this. Adam definitely came up with this brilliant idea of, say, let's use example ETFs for our elicited risk tolerance. And when we looked at the example ETFs, we chose 5 iShare ETFs. For our low risk, I think we chose money market, and for our high risk, we chose a gold index. But you could choose any assets into the 5 different categories for the elicited risk, and just say the proportion of those assets, and you can use a single assets in each of the categories, or you can use multiple assets in each of the categories. And then we're like, okay, so let's compare this to your portfolio. And I was saying, well, we have to be careful that we're measuring on the same assets. And so we ended up using both for the portfolio allocation and the profile allocation. So the elicited risk and the revealed risk, we used the same assets in each of the categories so that we were measuring on the same scale. And in the end, and we could understand the covariance for those matrices, and then we were able to calculate the value at risk for your elicited risk versus your actual risk. And so we were able to compare them. And what was interesting was, which is on the next slide, we can show this for a single individual. If you could go to the next slide, Leon. For a single individual, this is typical what happens is, we have a profile var, which is our elicited, and our portfolio average, which is our portfolio weighted average by the amount of each in each account. And so the client started with $0 in a cash account. That's what that means is a non-registered account. a 20K in an RSP, 300,000K in an RIF. This client's about 60 years old, 65. And so they were already retired, and which is why they have so much in their retirement income fund as opposed to their retirement savings plan. They had 65 in their TFSA and then 65 in a registered education savings plan. And so when they started with that, they had an addition of 600K into their account for whatever reason. And what we saw is that, there's a big change in their profile, their portfolios, right? A big change in their portfolios means a big change in their portfolio risk. And so they added that to their RIF, their non-registered account, and that kind of dropped their portfolio average down by, looked like about 50 basis points, maybe even less, 25 basis points, right? That purple line is the portfolio average. And so they changed something about their account, but they never changed their stated elicited risk, right? And so we can already see that you're changing how much you have at risk by decreasing the amount that you have at risk by investing in lower risk stocks, but you're not actually changing what you say that you want. And so we're always kind of comparing these two. We're always trying to compare that big purple line at top, which is your profile, versus your portfolio average, which is the purple line. And so we can able to tell, like, you're getting away from your stated goals even further. And so this is kind of a metric to be able to say, how well are you lining up with what you said in your KYC? And so in our next slide, we can actually look at this across the entire dealership for all 5 of the different clusters. And so I'll quickly describe the clusters here, and then I'll describe the graphs. The clusters from this research, in this research, we found 5 different types of traders. Right? We had our active traders, which is our people trading high-risk stocks, a lot of stocks trading very frequently in large amounts. They typically had margin accounts, for example. Then we had our early savers, which are people who purchase assets and then just sort of collect the dividends or reinvest the dividends. There's usually a large purchase right when they quote it on the first day of their account. We had the just-in-time traders, which is like the active traders, but smaller, not as often, just kind of more casual. So there's a little bit of difference there. Then we had the older investors, who were just very similar to the just-in-timers, except they're a little bit older. The types of accounts were a little bit different. And they were trading just a little bit differently and less. So that was just a cluster that showed up. And then there's the systematic savers that really took advantage of those third-party initiated. There's a third-party initiated. There's the other trade type, which is now completely escaping me. If one of my colleagues wants to jump in and tell me remind me what that was. It was the
Periodic?
No, the other one.
Systematic?
Thank you. Yeah, systematic savers, systematic trades. Should have saw that one coming. So the systematic savers were using mostly systematic trades. They were taking in those auto withdrawals of their account into their auto withdrawals or auto contributions, pre-authorized contributions, regular contributions to their account, and taking advantage of that. So we were seeing pretty much that was really separating a lot of the behaviors out from our clients, and that's how, and not really their demographic information. So now we'll switch back to thinking about VAR. On our left side, we have the elicited VAR. So this is when you're setting up your account, and then when you're updating your account, we're seeing these changes. What was interesting here is that the value at risk for the older investors is the lowest. They say that they're the lowest. And the highest are the early savers and the systematic savers. So those people who are doing a lot of saving and a lot of periodic saving we're saying that they had the highest risk tolerance. We expected the highest risk tolerance to be the active traders, but that wasn't the case. And then when we actually went to look at your portfolio value at risk on the right side, we found that, indeed, one of the things that will stick out to you, since these are on the same scales, is that the portfolio risk is just shifted completely down. And we'll talk about that in a second. But what's interesting here is, the older investors are the lowest risk profiles, which is sort of what you expect. And the systematic savers are pretty low. The early savers are pretty high in comparison, but we really didn't see that the active traders were, very high in their risk tolerance, which was an interesting result. And we talked about that. But, it did change a lot, since they're always actively trading and changing their account, while the others kind of sat on or changed their accounts not as often. And so if you go to the next slide, Leon, what I was saying a little bit earlier is that there's a huge discrepancy. So this is the elicited risk minus the revealed risk. And so but the thing is that they're all basically about the same discrepancy from their elicited from their revealed, right? There's only a 125 basis points difference here, so that's 1.25%. A lot of these are overlapping. I forgot to mention this, that the dark lines is the average, which a 95% confidence interval through a bootstrap surrounds those means. But you see that they're all decreasing. That's because everybody's profiles tend to be increasing. That really has nothing to do with their portfolio. So that's why you see that. You see a lot of the big changes in the active traders and having the largest discrepancy from what their stated risk is, which is they're much too low, right, in their portfolio. But you can see everybody here is about -200 to -350, right? And so everybody's being systematically under risked. And that is actually a result of how financial advisors are setting up their clients' accounts and advising them after they set up their risk. A financial advisor doesn't want you to set up with a risk and then you choose too much risk and then you lose a bunch of money and it's all their fault. And then the regulators come in and say, hey, you're over risking all your clients. We think that you're setting up your clients incorrectly. You're causing them to lose a lot of money. And now you have a lawsuit on your hands. Rather, they under risk all of their clients so that, you know, when the regulators come and say, oh, I see, you were trying to be safe with what they were saying because you were trying to protect their assets. Because no regulator is going to come to you in 30 years and say, hey, you set up this client's account 30 years ago. They didn't earn enough money, right, to be able to retire. And this is your fault. They're only going to say, well, you didn't lose them a ton of money. They gained a bunch of money, but they didn't quite gain enough. And that's just how the market works. And really, maybe they were under risked. And so what we think that financial advisors are doing is supporting their clients and making sure they're not going through losses that they can't handle. But our question is how can we, you know, what we want to discover next is how close can you get to what they're setting up there as to make sure that they're going to reach their financial goals, right? So if you under risk yourself too much over a long period of time, you might not reach the returns that you need to be able to retire to the lifestyle that you're interested in. And so this is a big question that kind of comes as a result of this work. But this was just some examples of how we can use, you know, financial metrics to be able to understand and better understand how we're seeing effects of financial behaviors and advice in our data set. And so that's kind of wraps up my portion on value at risk. And I think I'm going to pass the mic over to, oh yeah, okay, we can, sorry, one more slide. But so the couple advantages here, actually, one of the cool things here is it's actually a really useful tool to communicate between clients and advisors. Right, you know, it's not complicated to, it's complicated to say, oh, Adam, you have a risk score of 87, but I think you should have a risk score of 90 out of 100. And you'd be like, well, I don't really know what that really means. And you're like, oh, there's a couple examples I could kind of give you, but it's, you know, they're not directly relatable. We're just kind of, you know, coming up with ideas. And, you know, these assets have a 90 and you're at a 90, so you should buy these assets. And you're like, okay. I don't really know what a high risk bucket means. I don't really know what a low risk bucket means, but I trust you, I guess. Instead, it's saying, okay, Adam, I'm going to set you up with a 50% medium account. So on your worst day out of the next 100 days, you're going to lose, you know, 5% of account or, you know, $1 million because Adam's extremely rich. And so you're going to lose $1 million. And so are you comfortable with losing $1 million or worse on your worst day out of 100? And you say, you know, I'm not really comfortable with that. I think I'd be much more comfortable only losing $750,000. And you say, okay, so that I'm going to readjust your account. We're going to set you up with some low, medium, and medium, and you're going to get the value at risk that you want, you know, because, you know, if you lose this much, you'll still be able to afford the renovation on your 40 room mansion, like no big deal. And you'll be perfect. Yeah, this will be not a problem. I can be able to work with this. And so you're having these conversations about how much money you have and how much you could lose, and it's using metrics to be able to evaluate your risk that way, which are easily visualize and communicate to a client. It's a metric that's known by institutions. It's a metric that is known by regulators and compliance officers. So there's no additional, well, maybe there's a little bit of additional learning, but we're using financial ideas and concepts within the metric to be able to do that communication, which is why it's so advantageous to use these types of methods. So really incorporating subject matter into your modeling, into your feature engineering, into your analysis, you're going to have, you know, way easier time communicating with the people who are actually paying your bills, which is your clients. It's the companies that you work for, the companies that are funding your project. You know, that's what they're looking for, is that communication, using, you know, something that they understand and that you understand, that you know works well. Okay, so yeah, now I'm actually wrapped up. I forgot about the slide, so I think now I'm going to pass it off to Adam for real.
Okay, thank you, John. Thank you, Leon. That was great. I guess, Leon, if you want to stop sharing, I can start sharing. And as I'm getting my slides ready, any questions, any concerns, any comments about what we've been talking about so far? Everybody can see my screen? Okay. So what I'm going to do, I've got sort of two slide decks I'm going to splice together. The first slide deck is from a presentation I made probably almost a year ago, and it was sort of the first real big insights we had into financial resilience. So I mentioned an hour and a half ago, the lab has sort of two themes right now. And as you've seen over the last hour and a half, one of them is understanding investor behavior and the relationship between investor and advisor. Our second theme is quite distinct from that, and now we're just sort of thinking about the financial well-being, the financial health, the financial resilience of individual Canadians. And so I'll just give you an overview of where we started with this project. So we started probably almost 2 years ago, and so the Canadian Payroll Association, they do an annual survey every year, and they ask a variety of questions related to personal finance. How much are you saving? How much are you spending? What is your income? They'll ask a couple of questions like, you know, if this emergency came up and you needed $2,000 on short notice in an emergency, how hard would it be for you to find that money? They also ask questions about sort of your economic outlook and things like that. There's probably about, you know, on average 45, 50 questions in the survey every year. But the components of that survey, the actual questions they're changing, do vary a little bit through time. And so our original mandate, and this went back to the Fields-CFI days, was to explore 11 years worth of the CPA data and just kind of see what's there. So we didn't go into this with any preconceived notions. We didn't realize that we'd be learning about financial stress. It was really just a very exploratory exercise. Here is 11 years worth of responses to the survey. What's here? Tell us what we have. And so on the algorithmic side, some of the challenges that we faced were, number one, we've got the survey from 2009, from 2010, from 2011. Those surveys aren't exactly the same in every single year. And so you could have questions that appeared in 2010, but nowhere else. You could have questions that appeared in 2013, 14, 15, but nowhere else. And so the first thing we had to do was say, well, if we're going to compare, it's got to be apples to apples. So if we're going to compare our analysis from 2009 to our analysis from 2014, if those are going to be comparable, we've got to feed the same list of questions into the clustering algorithm, right? If I feed different inputs into the algorithm here and there, I can't necessarily directly compare those outputs because the algorithm was paying attention to different things when it put people into groups. And so that really narrowed it down to about 12 questions. There were 12 questions that were asked in every single year. And so we just fed those, you know, we took the 2019 responses to those 12 questions, did a cluster analysis. Took the 2010 responses to those questions, did a cluster analysis, and moved through time like that. Another issue was it's survey data, right? And so, you know, people don't necessarily fill out all the questions. Sometimes people say, I prefer not to respond to this question. So we had to think about what to do with responses to that. We had to come up with sort of thresholds that said, okay, if somebody answered half of these questions, do we include them? Do we feed them into the algorithm? Or do we set the threshold like you got to have answered at least 3/4 of the questions? And then one of the last decisions we needed to, or one of the last issues we needed to deal with was mixed data types. So a lot of the questions were Likert responses, so that's ordinal, right? Or ordered categorical, if you prefer that terminology. And some of them were categorical, right? So unordered categorical. And those are mixed data types and they're not numerical, right? You can't use a Euclidean distance here. And so we had to, we settled on something called Gowers distance. It can handle missing values. It can handle mixed data types. It can handle ordinal, categorical, numerical. It's been around for a while and we sort of suspect that it could probably be improved upon, but that was sort of the best thing that was available to us. And so that's what we used a silhouette with to decide the number of clusters, apply the separate cluster analysis to each year's response data. And what we got, and it was amazing, the results were shockingly consistent from year to year. In every single year, the algorithm clearly said there are 3 groups in your data. So we've got these people responding to the survey. We do 11 separate cluster analyses, and every single time the algorithm comes back and says there are 3 groups of people in here, and it doesn't often work out that consistent. Okay, so here's the thing. I'm just going to move back for a second. When you do a cluster analysis, the algorithm will put people into groups. It'll find the groups. The people in this group are similar to each other. The people from these 2 different groups are different. But it won't tell you what they have in common. So it won't say, this is what group A has in common, and this is what distinguishes group A from group B. It'll put people into groups and say, these people are similar, but it won't tell you why they're similar. And so this is where the sort of scientific side is running the cluster analysis. And if there's, there's as much art as science here sometimes, and the artistic side comes in going in and saying, okay, I know these people are similar. Why are they similar? And so that takes me on to our next slide. This is from the 2008 analysis. And so what I've got here on the far right, I've just got all respondents. We'll ignore them for the moment. And then I've got cluster A, cluster B, cluster C. So the algorithm put respondents into groups. I'm calling those groups arbitrarily for the time being, group A, group B, group C. And what I'm doing is I'm looking at how those groups responded to a specific question. And so the question here is paycheck delay. And the exact wording of the question is, or the nearly exact wording is, if your paycheck or the receipt of your pay were delayed for a week, how hard would it be to meet your obligations? So, and we're talking about a 1-week delay. How hard would it be to keep up with your bills, buy food, things like that? And so what you see is that, and it's a 7-point Likert response, and we collapse that down into 3 categories. Either it would be manageable, or the people were sort of non-committal. Yeah, I could probably handle it, but I don't really know. And then there was another group. The other option was it would be hard for me to deal with this delay. So what you see is cluster A, the majority of that group says, I'd be okay. And a very, very small group fraction of that group says, I'd have a hard time if I didn't get paid, if my paycheck was delayed for a week. And then if we zoom over to cluster C, only 4% of the people that the algorithm put into group C said they would be able to deal with the paycheck delay. And almost 2/3 of them say that they would have a hard time with the delay. And so we're kind of starting to see what distinguishes groups. And then we've got cluster B, which is sort of in the middle. And cluster B actually kind of resembles, I guess, the average respondent. So if we look all the way over on the right-hand side, this is how all respondents broke down. About 40% of all respondents said that the delay would be manageable, and about 1/4 of them said that it wouldn't be. And if you look at cluster B, they sort of resemble the average or the median respondent, if you will. So we're starting to see what distinguishes respondents. We've got one group that seems like they're financially resilient. If they experienced a brief setback, they would be able to handle it. And we've got another group that does not look resilient. If they experienced one of these delays, they would have a hard time bouncing back. So it looks like financial resilience is one of the things that's distinguishing respondents to this survey. So we move on and we look at other questions. And one of the other ones where we saw big differences were, how much are you able to save? And so I'll give you a moment to sort of absorb this. We see the same pattern. Group A, who we have yet to assign a label. The label A is arbitrary as yet. Group A are able to save better than Group B, who are able to save more than Group C, right? So savings habits are also part of this. The clustering algorithm didn't tell us it was paying attention to this question. We had to go in and dig and just sort of use, expert knowledge to realize what was going on here. And so again, we see what's starting to emerge is that if you imagine sort of a spectrum of financial well-being, we've got one group that is on one end, sort of good end of the spectrum, the healthy end, and we've got another group that is on the opposite end, that is on the unhealthy end of the spectrum, and then we've got another group in the middle. And what we'd like to be able to do, and this is kind of one of the big goals of the lab, is move people up that spectrum. How do we get people in cluster B into cluster A? How do we get people from cluster C into cluster B? Okay, and there were other questions. So I said earlier, we put the responses to 12 different questions into the algorithm. We saw big differences in the way the groups responded to some of the questions, like the two I've just showed you. Other questions like, how much do you trust that your pay is accurate? What do you think is going to happen in the economy over the next year? How much do you think you're going to need in order to retire? When do you think you're going to be completely free of debt? We saw almost no variation across groups in the responses to those questions. So even though we fed 12 responses in, the algorithm really only paid attention to 3 of them when it was putting people into groups. So there was the paycheck delay, there was the how much do you save, and then there was this question, which says, okay, if you were going to go to a new job, what would be more important to you? And there's a list of options: retirement funding, more wages, better work-life balance. There's about 8 things on the list. You could put those things into monetary things like more money, better retirement funding, and then you could put them in non-monetary aspects like good relations with my coworkers, better work-life balance, more time off. And so what we see is that group A places a lot more emphasis on the non-monetary aspects, presumably because their sort of financial well-being is in a good place. And you sort of think about Maslow's hierarchy, if you know what that is. Financially, they're okay. So now they start thinking about the other aspects of work other than just the paycheck. Okay, and this was sort of a new finding in the financial well-being literature, but I don't want to spend too much time on that right now. Okay, so what did we do? We put people into groups. The algorithm said these people are similar, those people are different, but it didn't tell us why. And so this exercise, the last 3 slides, was us understanding what distinguished the clusters, identifying the groups. As I mentioned, we've got 2 groups that are clearly on opposite sides of the spectrum. We'll call the one on this end financially comfortable and the one on this end financially stressed. We've got a 3rd group that lies somewhere in between. We called them financially coping. And concerningly, we did this over 11 years. 1/3 of respondents over that 11-year period were classified as financially distressed or financial stress. We found that financial stress is actually disturbingly widespread, right? If you think about what was characterizing that stress group, they'd have a hard time dealing with a 1-week delay in their pay. They're not saving very much. It's a precarious situation, and a lot of people are in that situation. So this was one of the sort of alarming things that popped out of the analysis. And what's even a little bit more surprising is that 90% of the respondents in this survey are employed on a full-time basis. And so we're looking at actually probably, if you think about the spectrum of the Canadian population, we're already zooming in probably on the financially healthier side of the spectrum, and financial stress is still disturbingly widespread there. Okay. One of the other insights we found was, okay, you might think, well, financial stress is concentrated in younger people. Older individuals have had a longer time to save. They've had raises. So you might think that it's demographics that determines financial well-being, and that's not the case. So you can see here that age has a bit of an influence. So if you're, 30% of the 18 to 29 age bracket was classified as stress. So one way you could think about that is there's like, if I pick, there's a 30% chance that a randomly selected individual between the ages of 18 and 29 is financially stressed. We look at people that were over 65, 50% of them were classified, as financially comfortable. So the older you are, the more likely it is the algorithm identified you as a financially comfortable individual, but age certainly doesn't tell the whole story. And surprisingly, we have 50% of individuals that are above retirement age that are not considered financially comfortable. And that's concerning to say the least, right? So what we see here is that age has an influence, but it doesn't tell the whole story. The older you are, the more likely it is that you're comfortable. The younger you are, the more likely it is that you're stressed, but age absolutely doesn't tell the whole story. What about income? What about gender? What about where you live? None of those things really matter. Income has an effect, but it certainly doesn't tell the whole story. So again, unsurprisingly, we see that the more money you make, the more likely it is the algorithm identified you as financially comfortable, but age doesn't tell the whole story. The median household Canadian income is, I think, about $70,000. We've got a bucket here of individuals whose family household incomes are over 150,000, which is more than twice the Canadian median. And still 50% of those individuals are not considered financially comfortable. 20% of them, 1 in 5, making more than double the Canadian median, are considered financially stressed. So again, income plays a role, income matters, but it certainly doesn't tell the whole story. And so this was one of the other really big take-home messages from our analysis was financial well-being, or lack thereof, your position on the financial well-being spectrum is not a simple function of demographics. It's not how much you make. It's not how old you are. It's not your gender. There's no difference there. It's not where you live. There were almost no provincial differences. It's something else, right? It's related to, so financial resilience is not determined by these simple demographic factors. So that was sort of round one of, those were the first kind of big insights we got when we started down this road. I can share in my 7 or so minutes left, I can share some more recent insights. As I am pulling those up, does anybody have any questions or concerns? And at this point, feel free to unmute yourself and interrupt. I can't see the chat and I can't see if people have raised their hands. So if you have any questions at all, go ahead and unmute yourself and let me know. Okay. So here is I'm now moving into a much more recent presentation. Actually a presentation we're going to be making on Monday. So this is kind of hot off the press. So what we did, our original analysis went up to about 2019. We did a few things in between. And recently we got the results from the 2021 survey. And we initially, when we started this at the beginning and we were doing our exploratory analysis and we didn't know anything about financial resilience, we had to restrict ourselves to questions that we're asking every single year. Now we've learned a lot more about financial well-being. We can sort of break from the past and say, okay, now we understand what's important and what's not. Going forward, we're going to start feeding more questions into the algorithm. We're going to eliminate the questions we found to be irrelevant, and we're going to add some questions in that we know now are helpful in distinguishing your location on that spectrum of financial well-being. And so what we did with 2021, we fed a very different list. We fed a much more appropriate list of questions into the clustering algorithm, still found 3 groups. And the groups are interpreted in exactly the same way. The hallmark symptoms now are debt and housing costs. Okay, and so we knew that stress group lacked resilience because they couldn't deal with brief financial setbacks. Now we're starting to get a much better idea of why that is. Okay, and if we understand why this is happening, there is a chance that we can help remediate it, right? And that's really the lab's ultimate goal is, if these are the things that are causing people to lack resilience, what can we do to nudge them and make changes, make different decisions that will help them move up the spectrum? And that's really what we're trying to do. We also found, thankfully, which sort of, what I just said, we want to move people up that spectrum. We actually see people in the data. We see success stories. We see people that were in this group in 2020 and were able to move into a higher group, a better group in 2021. So it is possible to move up this spectrum, and we can. And we're, the idea is to use, we're going to use some really deep ideas on sort of trying to understand causal relationships, deep neural networks, things like that. There is scope for helping people move up the ladder. So that's a good thing. Okay, so I mentioned that some of the hallmark symptoms are debt. So here, these graphs aren't quite as refined. Group 1 would be your financially comfortable group. Group 2 would be your financially coping, the middle group. And then group 3 would be your financially stressed group. And so the question here was, within the last year, I have used debt to pay for essentials such as food, clothing, shelter, whatever. And so what we see is that 2/3 of the group in the stress, 2/3 of the individuals in that stress group are using debt to pay for essentials. And that, is unambiguously a frightening and precarious situation to be in. Okay. And one of the things we notice is that along this axis, there's a really big gap between financially stressed and kind of everybody else. Okay. Another hallmark symptom is housing. All right. We asked, or the CPA asked individuals what fraction of their income that went towards housing. And, I think the CMHC recommends that no more than 30% of your income goes towards housing, and anything more than that is concerning. And we see that almost 80% of the stress group is exceeding the CMHC recommendations, right? And this is maybe leading to the need to use debt. If you're house poor, this is maybe leading to you needing to use debt to pay for essentials, and is leading to this lack of resilience, right? So we're starting to get a clearer picture of exactly what it is that might be driving the boat here, what might the access road to financial well-being be. And we have some ideas. Christian Bravo Roman from Western has some really interesting ideas on using some really cutting edge techniques to try and understand causal relationships here. Okay, and so I think this is probably where I will leave it. As I said at the very beginning, what we're trying to do with the lab is help people improve their financial well-being, help them become more resilient, help them make resilience enhancing decisions. If it's not possible for people to move up the spectrum, then the whole thing is DOA. What we're seeing here is that there is movement between clusters. We do see people sort of going up and going down. And so I should explain this. On the left-hand side, that is your group. So we looked at people who responded to the survey in both 2020 and 2021. We used the 2020 medoids. We fixed the boundaries from 2020 so that we could sort of have direct comparisons. I wish I could spend more time talking about that, but I can't. It can be tricky if you're sort of doing cluster analyses through times. You can have fluctuating boundaries, which makes it hard to compare. We came up with an idea to fix the boundaries and look at people in 2020 and 2021. We do see there are some people moving up. We'd like to help more of them do that. We do see some people moving down. We'd like to help them avoid that. And this is sort of getting people to move up this spectrum is sort of the lab's raison d'etre. I'm going to stop there because we are right at 11:30. Thanks everybody for your attention. I think we are going on break right now, strictly speaking, but I'm happy to sit